All right, I think I'm recording. We're taking a look at Skill 8F problems, and I'd like to do this problem in two different ways. One way I'd like to do it is, since this is in reference to angle B, I'm not going to use information about angles A or C, and I'm going to make the assumption that angle B lies in quadrant 1 to help me with signs, and that'll become more apparent in some later skill packets of how important it is to know what quadrant angle to know which quadrant your angle lies in, because sometimes you'll get answers of plus or minus. So if cosine of b is 4/5, and if I draw, let's make it a little bit better than that. If I draw a right triangle, and if this is angle b, and cosine is the adjacent side. So if I have 4/5 divided by 1, that's just 4/5. Um, let's figure out over here what the opposite side would be using the Pythagorean theorem. If I have 1 squared minus 4/5 squared, then why that's going to be, let's rewrite 1 as 25 over 25. Let's 4 squared is 16, and so now we have the square root of the fraction 9 over 25, which is equal to 3 over 5, right? And really, if I'd multiplied all sides of this by 5, you'd see that that's similar to a 3, 4, 5 triangle. That we're pretty familiar with that. Let's erase this, and the sine of angle B is the length of the opposite side divided by the hypotenuse. So hey, that's 3/5, and I'm done. Okay. Now another way that we could do this, um, we know that's using Pythagorean identity, that sine squared of b plus the cosine squared of b is equal to 1. So I know that the sine of b is equal to 1 minus the cosine squared of angle b. And if I take the square root of both sides, if I am assuming the angle B lies in quadrant 1, I only have to worry about the positive square root. I don't have to put a plus or minus symbol there. So if I am given that the cosine of B is 4/5, and we're squaring that, and so it's the same as the previous work, that I'm going to rewrite 1 as 25 over 25. When I square this, I get 16 over 25. When I subtract 25 minus 16, I get 9. And the square root of 9 is 3, and the square root of 25 is 5. So I get, again, whether I use the trig identity or just information I know about um, special right triangles, or Pythagorean theorem, I guess, 3, 4, 5 triangle, um, I get the same answer. So let's take a look at the next one. Maybe we can do it real quick as well. Secant of C. Um, let's not worry about angles A and B. Let's look at the tangent of C. All right. So I have a trig identity that says that the tangent squared of angle C plus 1 is equal to secant squared of angle C. So I guess I can write that on the left-hand side, right? I can just move this over so that you already have secant squared of theta. Now, if I'm assuming that angle C is in quadrant 1, when I take the square root, I don't have to worry about plus or minus symbol. And they give me that what did I put theta? I changed the angle. I got to pay attention to what I'm doing. This is C, and I'm so used to writing theta, but our angle here is C. Sorry about that. Tangent squared. I'm also listening to the Bob and Tom show as I'm doing this, so it kind of distracts me and makes me laugh. There's a guy, John Fox, that's on there right now. He passed away, but was a pretty funny comedian. Let's get a common denominator, 4. So the square root of 4 is 2, but I can't simplify the square root of 29. So I'm getting the square root of 29 over 2. Now, is there Yeah, there's, that's using identity. If I had just jumped in and used a right triangle. So let's do this again. Um, Say that I am given the tangent of c is 5 over 2, and that I come in and say, well, if this is angle C, and if the tangent is 5 over 2, that I could say the length of the opposite side is 5, the adjacent side 2, and come up here and say 5 squared plus 2 squared is 29, that the hypotenuse is the square root of 29, and the secant of angle C being the inverse of cosine, or just by definition, is r over x is the hypotenuse, is square root of 29 over 2 by definition. It's the hypotenuse divided by the adjacent side. That's what the secant is. So I get the same answer. So I've got multiple ways to get the same answer, just kind of depending, I guess, in the way that you look at it and how you view it. Do you find it easier to do right triangles and use Pythagorean theorem? Do you find it easier to be familiar with those trig identities? You got to force yourself probably to try it multiple different ways, because there are going to be times when you're going to be forced to use the trig identities. So this time I got away without using them, but that's not always going to be the case. So I hope that helps, and I will talk to you later.